Now that we have seen what the sensitivity of a thermometer means, let us turn our attention to look at the precision of a thermometer. I think this concept can be best illustrated by using an example. Okay, but before that, let us look at the definition first. The precision of a thermometer refers to the smallest possible temperature difference measured by the thermometer. Assume that we have two thermometers. Let's call the thermometer on the left as X and the thermometer on the right as Y. Assuming that both thermometers are now placed at room temperature, so they will both register a reading of 28 degrees Celsius. Next, let us say that there's an increase in temperature of 5 degrees Celsius. This increase in temperature will cause the mercury in the thermometer to expand. This means that the volume of the mercury will increase, right? This increase in volume will result in an increase in the mercury level. If we assume that the volume of mercury in both X and Y is the same, the amount of expansion in both X and Y will be the same. But although the expansion is the same, the mercury level in X will rise by a larger amount because of the smaller diameter of the capillary bore. So let's say it rises to this amount to read 33 degrees Celsius. For Y, the expansion only result in a small increase in the mercury level because of the larger diameter of the capillary bore. So this will rise by a bit to read 33 degrees Celsius. Thermometer X is said to be more precise than thermometer Y because it can detect smaller changes in temperature. Okay, so now take for example, instead of the temperature increasing by 5 degrees Celsius, the temperature now increased by 1 degree Celsius only. This 1 degree Celsius increase in temperature will result in an expansion of the mercury inside the thermometer, right? Although the expansion is now less than that when the temperature increased by 5 degrees Celsius. Okay. In thermometer X, this 1 degree Celsius increase will probably still result in an increase in the mercury level to about this level as marked in green. So this will read 29 degrees Celsius. However, if you look at thermometer Y, because the diameter of the capillary bore is bigger, this 1 degree Celsius increase in temperature will not be able to result in a perceptible increase in the mercury level. So which means to say that the mercury level will still increase by a bit, but because the increase is so small, you can't really measure it. This explains why thermometer Y is less precise than thermometer X. Okay, so precision is talking about how well the thermometer can detect small changes in temperature. The more precise it is, the better it is at detecting smaller changes in temperature. Okay, alright, so we have seen that the capillary bore is one factor that can affect the precision of a thermometer. What are the other factors that will affect the precision? The second factor that will affect the precision is the volume of the bulb. Let's say for instance again, we have got two thermometers. The thermometer on the left is thermometer A and the one on the right is thermometer B. For this example, we will assume that the diameter of the capillary bore for both thermometer A and B is the same. Okay, so just to keep that constant, but we vary the volume of the bulb. So for a bigger bulb, which is thermometer A, yes, it contains a larger volume of mercury. So let's say we start again from room temperature. Both will register a reading of 28 degrees Celsius. Now that there's a 5 degrees Celsius increase in temperature, this increase in temperature will cause an expansion of the mercury in the thermometer. If you assume that 5 degrees Celsius increase in temperature will result in a 10% increase in volume, the volume of mercury in thermometer A is larger. This 10% increase in volume will result in a larger increase in the actual volume. So let's say that A initially has 100 milliliter of mercury inside, whereas B has only 10 milliliters. If there's a 5 degrees Celsius increase in temperature, 100 milliliters of mercury in A will become 110 millimeters, whereas the mercury in B will only become 11 milliliters. For A, this is an increase of 10 milliliters, whereas for B is just an increase of 1 milliliter. Okay, assuming that the capillary bore for both A and B is the same, it's logical to deduce that the mercury level in A will increase by 10 times that of B, right? So B will only go up by a bit. Okay, so what we see here is both experience a 5 degrees Celsius increase in temperature, but A register a larger increase in the mercury level in the thermometer because of a larger volume of mercury it initially has. So this is very similar to the example that we talked about previously. If the thermometer registers a larger increase due to a change in temperature, it is said to be more precise because it means that it can detect smaller changes in temperature. In this case, A is more precise than B. So that's it for sensitivity and precision of a thermometer. But before I end it off, I would like to point your attention to the fact that volume is a factor that affects both the sensitivity of a thermometer as well as the precision of a thermometer. Okay, just that it has got different effect. For sensitivity, when volume of the liquid in the thermometer decreases, the sensitivity goes up. Whereas for the case of precision, when volume goes down, precision goes up. As in the case of this thermometer B, when volume is smaller, the precision is lower. Although volume is a factor for both sensitivity and precision, it has got opposite effects on these two properties of a thermometer.